Alright, let's have a look at the reasoning, which is all about area and volume today. And we start off with Rosie and Dexter, who are creating shapes with an area of 30 centimetres squared, and I'm assuming who is correct, so maybe someone's wrong, maybe someone's right. To explain, I'm just going to find the area of the shapes. Remember, area, length times width. So, I've got 0.5 centimetres times 60 centimetres, which would give me 30 centimetres squared, because 0.5 is the same as a half, so it's a half of 60. 30 centimetres squared, so Dexter is correct. On Rosie's, it's compound shape. It's shapes stuck together to make a new shape. So I'm going to split it. There we go. To find this area, I'm going to do the length, which is 10 times 2 to get 20 centimetres squared. Ollie's whining, he wants to walk. That's 5. If all of this side is 4, and this part of it is 2, I know from up there, then this part of it must also be 2. So now I can do 5 times 2, which is 10 centimetres squared. Add them together, 30 centimetres squared. So Rosie's correct as well. Well done, both of those. Next up, we've got to draw rectangles with an area of 24 centimetres squared where the side lengths are integers. And what do we notice about those side lengths? So integers are whole numbers, so I can't go into decimals here. What I notice is they're the factors of 24. So I could do a rectangle that's 1 centimetre by 24 centimetres, 2 centimetres by 12, 3 by 4, or why have I put 6 times? Oh, I made 12 there, forgive me. Making 24, not 12. What was I doing? 24, so it's 6 by 4. Or I've already got 12 by 2. And that's the lot. Oh, 8 times 3. There we go. Or 3 times 8. 3 by 8, 6 by 4, or 4 by 6, 12 by 2, 2 by 12, 1 by 24, 24 by the factors of 24. Then, have a look here. Using integer side lengths, so again, whole numbers, draw as many rectangles as possible that give the following areas. So because we're using whole numbers, it's limited our options significantly, and it's no surprise that they've started with a prime number. So the only rectangle with integer sides of 17 square centimetres would be 1 by 17. For 25, I can do 5 times 5 is 25, and 25 by 1. And then for 32, a bit like the 24 question up there, it's the factors of 32. So I could do 16 by 2, I could do 8 by 4, 1 by 32, the factors of 32 to make those rectangles. You might be thinking, oh, it's a square, not a rectangle, but mathematically a square is a rectangle because it has 4 right angles and the 2 pairs of opposite sides are equal. We add for a square the extra description that those 4 sides are the same length, but still a rectangle. We go down now to look at these triangles. So to calculate the height, that should be area of a triangle, by the way. To calculate the area of a triangle, you can use the formula base times height divided by 2. So we've got to choose the correct calculation to find the area of this. So the base of the triangle is 10 centimetres and its height is 4. That 5 is there to confuse us, so we would do 10 times 4 is 40. 40 divided by 2 is 20 centimetres squared. So the area is 20, and it's that second one there, look. 20. Do base 10 times the height of 4 divided by 2. Now here, we can estimate by counting the squares. Let me just zoom in. There we go. The squares and part squares before we then calculate it. Excuse me. So it's base 1, 2, 3, 4, 5, 6, 7, 8. So its base is 8. Its height is 1, 2, 3, 4. So I need to do 8 times 4, which is 32, and then divide it by 2 to get 16 centimetres squared, or 16 squares. We aren't told the centimetres. Then we've got to calculate the area of each shape. They're all made of triangles, and here we've got to find the correct information to use. So its base is 5 times 12, which is 60. 60 divided by 2 is 30. here. So I don't need to use, this side of the triangle, the longest side is called the hypotenuse, which you'll come on to when you're in year 7. But we would do the base of 5 times 12 is 60, 60 divided by 2, 30 centimetres squared. And here, that's not a T, that's there we go. I can actually do 7 times 1, and I think the area of this whole shape is going to be 7 centimetres squared, but that's because if I found one triangle and doubled it to find them both, I'd get 3, the height of this one would be 3.5 and its base is 1, excuse me. So I can times it by 2, excuse me, I just got a message, 3.5 times 1 divided by 2, we're going to get 7 centimetres squared. Over here, my diagram looks a little bit messy there, let me show you one here. So we've got the base of 6, the height of 4, so 6 times 4 is 24, divided by 2 is 12. So each triangle is going to be 12, and then I'm going to double it to make 24, so a bit like the previous question. Really, if we just do 6 times 4, we've found the whole area of this parallelogram. We don't need to have it because if you imagine if I cut that part off the triangle, I could put it over there and it would make a rectangle where we would do length times height, 6 times 4, so 24 centimetres squared. Next up, we've got volume. So to find the volume of a shape, we do start with the rectangle, length times width, then times it by the height. So we've got 3 dimensions to multiply. So for this one, we do 4 times 3 times 2 in any order, but we get 24 centimetre cubed. First off, though, we're counting cubes to find the volume of each solid, of each shape. So we can see the first one, 1, 2, 3 centimetre cubed. 1, 2, 3, 4, 5, 6 centimetres cubed. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 centimetres cubed again. Now here, multi-link cubes, you could use Lego, however, but we might be good at visualising, imagining, to find the volume of each shape. Because what I would do, the ones I can't see that are like underneath there, well, I know there's 1, 2, 3, 4, 8, 12. That top piece is 12. So underneath it here, there'd be another 12, so that's 24, and then I can add these ones on there. 24, 25, 26, 27, 28 for that one. Same over here. I've got 1, 2, 3, 4, so there must be another 4 in there. 1, 2, 3, and the one that's under there would be another 4, so that's 8, 9, 10, 11. We get 11 centimetres cubed for that one. Here, this must be, I can see 3 of the tower, but there must be one underneath it to support it. So that tower in the corner there is going to be 4, 5, 6, 7, 8, 9, 10, 11, 12. I think 12 centimetres cubed there. Oh, tricky one here. So, 1, 2, 3, 4. So each row of, I'm going to imagine I'm going to find this square here. So that's 4, 8, 12, 16 in that piece there. I'm going to make a note of 16 to keep track of this. Then I've got another 4 in that row. So that's 4, 8, 12 in that slice there. Jot that one down. Then I've got 1, 2, 3, 4. So there must be 8 in that slice and another 8 in that slice. So that piece there has got 16 in it. Jot that down. And then I can see all of these ones. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just going to check. 2, 4, 6, 8, 10, 11. So if I add my little notes there, 16 and 16 is 32. Then I'm going to do 2, 4, 5, 30, 40, 55 centimetres cubed. That made me think. There we go. So remember, volume, length times width times height. So on here, if I use the length, and I'll look at over here, the length of this one would be 5, the width would be 3, and its height is 4. On here, we've got 3, that one is the same as that length, same as that length, so we could do 3 times 1 and then times it by the height of 5. The area of the base, then, that's what we're working out first, the bottom face. So on this one, we could do 5 times 3 is 15, that goes there, and then we times the area of the base by its height. So we're going to do 15 times 4, which is 60 for that yellow one. The green one, I'm going to do, remember that 1 goes over there, so I can work out its base as 3 times 1, which is 3, and then do 3 times 5, which is 15 centimetres cubed. Okay. We have a look over here. I'm doing this one first because I think it'll help them with this one down here. There we go. So we've got to work out the unknown height of the cuboid. And you could use Lego, you could build it to help you. Okay. So we would use 32 cubes, or 32 pieces. If you're using cuboidal shapes, not cube shapes, you'd have to imagine that they're all 1 centimetre by 1 centimetre. But basically, to work out the answer of 32, they must have done 4 times 2 times something to get 32. Which is just inverse gap fill then. 4 times 2 times something is 32. Well, 4 times 2 is 8, and 8 times 4 makes 32. So its height must be 4 centimetres. There we go. Now we've got to calculate the volume of a cube with a side length of 4 centimetres, then another of 2 metres, then another of 16 millimetres. So what we need to do, we have to draw a cube. Make these as square as possible. So just to show you where and why those answers are coming from. Okay. So each side is going to be 4 centimetres. So base width. There we go. So we do 4 times 4 is 16. 16 times 4 will give us the total volume. 24. 4 add 2. 6. 64 centimetres cubed. Same again on the next one. I'm going to show the volume in cubic metres. So it would do 2 times 2 is 4. 4 times 2 is 8 cubic metres. Really, we're doing 2 cubed. 8 cubic metres. Next up, 160 millimetres. I'm going to turn that into centimetres because I think it's going to be easier to work with, which would be divided by 10, 16 centimetres. So I'm going to need to do 16 times 16 times 16. Start off doing 16 squared, and then I'll times that answer by 16. 0 the hero. 6 squared is 36. 6 times 1 is 6. Add the 3 makes 9. 6 times 1, 1 times 1. Add those together. 256. So now if we do 256 times 16, we'll have the total volume. So 6 squared is 36, is 30, add the 3 makes 33. 6 times 2 is 12, add the 3 makes 15. Oops, sorry. Times it by 1, not by 10 but by 1 for us. 6 times 1, 6 times 1 times 5, 1 times 2. Add those together. 9. It was meters, wasn't it? 4,096 cubic meters. Very large cube indeed.